Hello student, in this video I would like to start from the last video as a continuation. We are going through the sampling topic in this course. So now uh, I would like to start from this point, that is post stratification. Stratification is sometimes introduced after the sampling phase in a process called post stratification. So what is this approach? This approach is typically implemented due to a lack of prior knowledge of an appropriate stratifying variable, or when the experimenter lacks the necessary information to create a stratifying variable during the sampling phase. If a experimenter or a researcher cannot create a stratifying variable or does not have any prior knowledge to create an appropriate stratifying variable, then post stratification is done. Although the method is susceptible to the pitfalls of post hoc approaches, it can provide several benefits in the right situation. Implementation usually follows a simple random sample. In addition to allowing for stratification on an ancillary variable, post stratification can be used to implement weighting, which can be improve the precision of a sample estimation. Oversampling. Choice based sampling is one of the stratified sampling strategies. If you go for choice based sampling, that is also belong to a stratified sample strategy. In this, data are stratified on the target. Data are stratified on the target, and a sample is taken from each strata. Data are stratified against the target. A sample are taken from each strata, or we can say group, so that the rare target class will be more represented in the sample. So that is why this is a choice based, because we are trying to choose those sample which should belong to rare target, which will represent more in the sample. The model is then built on this bias sample. So after collecting those sample in which rare samples or rare target classes also belong in large number, then that sample become a bias sample. Then we can create a model, or we can build a model on that bias sample. The effects of the input variables on the target are often estimated with more precision. So the effects of the input variables on the target are often estimated with more precision with the choice based sample, even when a smaller overall sample size is taken compared to a random sample. The results usually must be adjusted to correct for the oversampling. So that is how, in that way, the results usually must be adjusted to correct for the oversampling. So to tackle the oversampling, we can go for choice based sampling. So actually we are trying to go for cluster based sampling. So we need to identify the clusters. Clusters will be like list all cities, towns, villages, and wards of cities with their population falling in target area under study. Calculate cumulative population and divide by 30. This gives sampling interval. So if you divide those cumulative population and divide by 30 or any integer number, then you will get a sampling interval. Select a random number less than or equal to sampling interval have same number of digits. So now try to select a random number less than or equal to sampling interval. Here you have taken 30, you might take 29, 28, less than or equal to sampling interval having same number of digit. Here there is 32 number of digits in the sampling interval, so you try to take a random number having 2 digit. This forms first cluster. So this forms first cluster. Okay, random number plus sampling interval equal to population of second cluster. Second cluster plus interval equal to fourth cluster. So in that way you try to go on to create the cluster. Last or 30th cluster equal to 29th cluster plus sampling interval. So in that way you can get the cluster. So two types of cluster sampling methods are there: one stage sampling, two stage sampling. All of the elements within the selected clusters are included in the sample. All of the elements within selected clusters are included in sample. But in two stage, a subset of elements only within the selected clusters are randomly selected for inclusion in the sample. So there is a difference between one stage and two stage sampling, because in one stage sampling, to create a cluster we try to select all the elements which are within the selected clusters, but in case of two stage sampling we try to take the subset of elements from the selected clusters using random or try to do that using random numbers, or randomly selected elements is selected from the selected clusters for inclusion in the samples. So here you can see there is a different type of cluster name: cluster sampling, cluster 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Those are actually cluster name number, and that is sampling interval is 3000. Frequency is here you can see cumulative frequency. So 1, 2, sampling interval is 3000. Okay, so in that way we can get the clusters of different interval and try to understand how we can generate the. So try to go to the book also how we can create these clustering samples. You can get an idea from this one slide. How can we go through? There is a difference between strata and clusters. Before this cluster sampling technique, we have discussed about stratification or strata or stratum. But there is difference between strata and clusters. Although strata and clusters are both non-overlapping subset of the population, they differ in several ways. All strata are represented in the sample, but only a subset of clusters are in the sample. So here you can see all strata are represented in the sample, but only a subset of clusters in the sample. With stratified sampling, the base survey results occur when elements within the strata are internally homogeneous. So the elements should be homogeneous. However, with cluster sampling, the base result occur when the elements within the clusters are internally heterogeneous. So very huge difference in case of homogeneous and heterogeneous among the elements in the strata or in the clusters. So that is a very huge difference between strata and clusters, and significant one. There is also multi-stage sampling, complex form of cluster sampling in which two or more levels of units are embedded one in the other. First stage, random number districts chosen in all states, followed by random number talukas, villages. Then third stages on units will be houses. All ultimate units selected at last steps are surveyed. So suppose you are going to do a survey, you try to first choose the random numbers, try to cluster them, and then go for the random number of talukas or villages or societies or districts, or we can say towns or municipal areas inside those districts. Then you can go for in the third stage, which where you are going to for the last stage actually, which are the ultimate units, which will be the houses. Houses, for instance, those are the actual instance, or you can say elements of our study, or we can say elements of the population selected at last steps to be surveyed. So that is the multi-stage sampling, but this is a complex clustering formation. First you try to cluster this first in the first stage, then you go down to create the second stage, and in the third stage you go for the ultimate units of the population. This technique is essentially the process of taking random samples of preceding random samples. Not as effective as true random sampling, but probably solves more of the problems inherent to random problem or random sampling. An effective strategy because it banks on multiple randomization, as such extremely useful. So actually this process of multi-stage sampling creates a more randomness than the simple random technique. So that is why it might be very extremely useful in some cases. Multi-stage sampling used frequently when a complete list of all members of the population not exist and is inappropriate. So multi-stage sampling used frequently when a complete list of all members of the population not exist initially. Then only initially, or might be the list is inappropriate, then obviously you need to go in a random way to choose the initial list or initial in the first stage itself. Then you can go down to create the second list or second stage, and then onwards to find the ultimate instances for your population. Moreover, by avoiding the use of all sample units in all selected clusters, multi-stage sampling avoids the large or and perhaps unnecessary cost associated with the traditional cluster sampling. So actually what happens is that when you try to go from the top to bottom, from first stage to second stage to third stage, you go through a random sampling technique. So you already try to avoid large and perhaps unnecessary cost during that process, because you are going to choose only those randomly selected districts or talukas or villages, not all the districts, all the villages, all the talukas. That is why you are avoiding that unnecessary or large cost associated with the traditional cluster sampling techniques, because that is why multi-stage is useful in case of larger data set where you don't have initial list or appropriate list initially to create the cluster. Then there is multi-phase sampling, which is a part of the information collected from the whole sample and part from the subsample. So here part of the information collected from the whole sample and part of the information collected from the subsample. Suppose in a TB survey, empty in all cases phase 1, X-ray says in empty positive cases phase 2, sputum examination in X-ray positive cases phase 3. So here there is 3 phases, but in all these 3 phases 3 different type of survey or information is collected. So survey by such procedure is less costly, less laborious and more purposeful. So this is multi-phase sampling because because every phase is different, not related. But there is, you might ask that why multi-phase and why multi-stage branch it out differently, because multi-stage has a connection at least. We can go for the second stage from the first stage, not directly to second stage, but here you can see that the phase is depends, or phase is divided among depending upon the information collected. Because every phase has different meaning or different way to collect the information, or different type of information is collected in every phases. Here you can see in TB survey, suppose empty in all cases, phase 1, X-ray cyst in empty positive cases, phase 2, sputum examination in X-ray positive cases, phase 3. So that in that way you can create a different phase for sampling. So this is a multi-phase sampling technique. Next one is matched random sampling, a method of assigning participants to groups in which pairs of participants are first matched on some characteristics and then individually assigned randomly to groups. The procedure for matched random sampling can be briefed with the following context. Context is like that: suppose two samples in which the members are clearly paired or are matched explicitly by the researcher. For example, IQ measurements or pairs of identical twins. Those samples in which same attribute or variable is measured twice on each subject under different circumstances, commonly called repeated measures. So, example include the times of a group of athletes for 1500 meter before and after a week of a special training, the milk yields of cows before and after being fed a particular diet. So why this is matched random sampling is that we try to random the sampling, but we try to create a matching, because there is two sets of sample. One is before a timeline, one is after a timeline, might be different table. Here you can see, suppose if you want to measure IQ levels of two identical twins, then for two people there will be two separate entries for twins, separate entries, but attributes will be same. So we can match the twins, or we'll match the twins, but we'll try to choose those things randomly. So here, that is the thing about matched random sampling, where we try to go random sampling, but we try to match in this type of scenario where we need to match the inputs between two timelines or between two different dataset tables, or measurement values of two uh, different entities. Here you can see 1500 meter. When you try to understand the times of a group of athletes for 1500 meter before and after a week of special training, so then you can understand the performance of that athlete group, and then also to understand the milk yields of cows before and after being fed a particular diet. So in this type of research you can go through this type of matched random sampling. So we'll go through next other techniques of sampling in next video. Please try to go through the topics or elements we have discussed, I have discussed in this video. Try to go through the books also, try to go through the literatures also. If you have any doubt, please let me know. Thank you.